although for this problem, to solve it, the first part, what is the distribution? Now this is just for any randomly selected one. The mean and the standard deviation is what you would use. And so they took it, lower this a little. Mean was 16, standard deviation 6. But then here we're talking about an average distribution. Taking a sample instead of from the population. The mean is still the same. Let me open all these first so you can see them. Okay. So the mean is still the same, 16. But the standard deviation is not. What it is you take the standard deviation that they have for the population and you divide by the square root of n. I put equals 6 because that was the standard deviation divided by square root returns the square root of n. N is how many there are, and our sample is 34. And we get the 1.029. So it's standard deviation divided by the square root of the sample size. For part C, what is the population that one randomly selected person drinks between 15.7 and 16.4 ounces of coffee per day? So since we want between, when we find the percent using the normal distribution, it gives us the percent below. So if we put 16.4, it's going to give us from 16.4 all the way down. So then we want to find 15.7 and subtract that part out. If we subtract from here over out, then we're only left with what's in between. So you find both and subtract them when they want in between. Another thing, this part C is one randomly selected person. So one randomly selected uses part A, the distribution for just an X. So if we find one now, I'm going to put it here. I'm going to click here and put equals and type normal. Now, when you want a percent, it's the first one. If you have a percent, then it's the second one. It gives you the number. And when you click on it, double click, it tells you what to put. First, we put our X value, which was 16.4, comma, our mean, and we're using the first one because it's one randomly selected person. So it's 16, comma, standard deviation was 6, and then cumulative, it adds up to 1 under your curve, so it's a 1. And then hit enter. Now this is the amount below 16.4. We need to do the same thing, equals norm, we want distribution, and we're going to do the same thing, only we're going to use the 15.7. 15.7, comma, 16, comma, 6, and a 1. Enter. This is the amount below 15.7. So if we subtract these, equals, and you don't have to type it out, you can just click on it. So this one minus x1 and hit equals, and there's your answer. 0.0465. Part D, notice the difference between the two. This one says one randomly selected person. This one says 34 people. So it's a sample. Because it's a sample, it's still going between the same. But because it's a sample, instead of using this standard deviation, you're using the 1.029. How that got in there. 1.0. So it's the same process, except we use the other standard deviation. Now, if you wanted, you could click on this one, was the 16.4. Right here, the 16.4, and then just change your standard deviation. Standard deviation is 1.029. And then on the second one, the same thing, change the 6, 1.029. And then it subtracted it already, and here's our answer, 2.66, 0.266. So what I did was I just clicked on here and I changed my 6 right there to 1.029 on both of them. And then this one, it's still subtracted after I changed my values. Part E, is the assumption that the distribution is normal necessary? It is not necessary because your sample size is greater than 30. So if it's 30 or more, it's large enough that you don't have to say that it's normally distributed. So greater than 30, you don't have to say it's normal. The next group is using percentiles. Q1 when they're working with quartiles, and this one was Q1 and Q3. Some books use QL for lower and Q3 for QU for upper, but yours uses Q1. So when you have a box plot, there we go. It starts with the smallest number, and then it has the Q1, the lower quartile, and your middle number, the median, and then the upper quartile, and the largest number. These are broken into quarters. So this is 25% of the data. This is 25. This is 25. And this one's 25. So if you're looking for Q1, or the lower quartile, 25% of the data is below it. So it's called the 25th percentile. When you're finding percentiles, it's the same thing then. That's the percent below. So if we look at Q3, below it is 25, 50, 75% of the data. So Q3 is a 75th percentile. So looking for Q1, we use 25%. You're looking for Q3, 75%, because 75% of the values are below it. 25% above. If we go back to our number, if we're finding Q1, that means 25% of the data is below it. And it's using the average of 34 coffee drinkers, which means we're using B and not A. If it said a random sample, then we'd use A. So 34 coffee drinkers. Well, we're going to do equals a norm. But in this case, we're using 25%. We're finding the number of them. And so then you use inverse. Because when you use inverse, it asks for the probability, which was 25% as a decimal, then your mean, which was 16, and the standard deviation. Since this is a sample of 34, we're using the 1.029. So approximately 15 coffee drinkers. But they wanted you to round it 4 decimal places. Q3, 75th percentile. So we do the same thing, equals norm, and we want the inverse because we have the percent, we're looking for the value, we're doing the opposite. You put your probability, 0.75, comma, your mean, and 1.029, and hit enter. 16.6941. Interquartile range is just these two subtracted. To define the interquartile range, I put my equal sign, the second one minus the first one. Enter. You get 1.3882. Now, I used rounded further. If I would have used the 16.6941 minus 15.3059. So I used a further decimal, and